Hi, I want to talk about what it takes to hack one of these binary files and properly fill in the image type, width, height, number of images, and whether or not it's a little Indian. So I just want to go through uh, how we approach a problem like this. For your interest, I have posted the Mathematica program that I use to create all of the homework sets, both version 1, version 2, and version 3. And version 1 is saved on Moodle with the answers encoded in the file name. So when we look at all of the people, Rebecca here. Rebecca's got one of the tougher ones perhaps. Unsigned integer 16, little Indian, 256, 244, 110. And well, we try and see if we can hack this one, pretending we don't know the results. All we really know is that it's a binary file with 13 million bytes. So one of the things we want to do is compare that size versus what we expect to see. 13 million. We expect to see something on the order of 256, 256, 110, or a little less. So we see that Becca's file is about double. And that, since we know the answer, we do know that it's 16. So it's 2 bytes per number. If we were to divide by 2, we see that Rebecca's file probably has a somewhat smaller dimensions than 256, 256, 110, giving us 6,800,000 voxels, not the 7.2 million voxels that the uncropped image has. So just by the size and knowing the dimensionality of what we're supposed to get, we're already clued in that we are with 2-byte numbers, either 2-byte integers signed or unsigned. So we're making progress. And then, what are the possible rows, columns, and slices? How do we factor 6,800,000? Well, there's 11 2s, a 5, an 11, and a 61. We know that it could be as many as 110. I see an 11, and I see a 5, and I use another 2, I'll get 110. So let me go ahead and say that the number of rows is, I could do something like use that 5 and that 2, one of the 2s and the 11s, and take care of my number of slices. Leaving behind a 61. Probably a 4, 244. Okay, so I've used up 3 of my 2s. That'll leave me with 8 2s. 2 raised to the 8th power. Yeah, okay. So I'm thinking that we probably have dimensionality of 256, 244, 110. We know in advance that 110 is the number of slices, or number of images. So the width and height, it's these 2 numbers. So let's pull up ImageJ and start trying a few things. Import raw. So let's start off with signed, because we know the answer is unsigned. Start off with sign. What's the answer supposed to be? 256. Let's do it wrong. 244, 256, 110. We know it's little. Let's do big. Well, this is a sign, indication that at least rows and columns are interchanged. I'm putting the cursor over here to the upper left because I know in advance that's likely to be error and either 0 or at least very small. And I'm looking at the numbers that are shown on over here. I see 0. And I'm going to these numbers. Well, these numbers are possibly good. Let's keep going. Let's keep going. Let's kind of remember what we've done. Read it again. I said we needed interchange. Let's do just that interchange. Okay, the shape's good. Error is 0. Something funny going on here. We got error and we've got negative numbers. Okay, so I think we're at the place where width, height, and number of images is correct. It's either we're off here or we're off here. Let's see if this will fix it. Not so good. Now it could be both of them. Let's go to unsigned. And that's looking pretty good. At the moment we're big Indian and my code says it's little Indian. This is either telling me that I have an error in my code, or we got a case where this particular data set, it doesn't matter. I have to think about this. But basically that's the analysis procedure we go through to hack one of these unknown binary files. Hope it was fun for you. Bye-bye.